This is half past paper week 10 for the higher. So this is all the even numbers. We did the odd numbers last week on week 9. These are all of the topics we're going to go through today, and the Sparks codes. If you do have Sparks at your school or you've got access to Sparks, then you can do more questions by searching up that code on your independent learning. If not, you've got the topics there for you as well. Okay, question number 2. On the grid below, draw the graph of y equals 2x minus 3 for values of x from minus 2 to 4. So for this, we're going to do a table of values. X goes on the top, y goes on the bottom. And I want to do values of x from minus 2 to 4. So that tells you that alongside x, we need to go minus 2, minus 1, 0, 1, 2, 3, 4. And then this is the rule. It says to get y, you need to do 2 lots of x, take away an extra 3. So I'm going to do 2 lots of x. So I'm going to start with this one. 2 lots of minus 2 is minus 4. Take away another 3 is minus 7. And then I'm going to do 2 lots of minus 1, which is minus 2. Take away another 3 is minus 5. Then I'm going to do 2 lots of 0. 2 lots of 0 is 0. Take away 3 is minus 3. 2 lots of 1 is 2, take away 3 is minus 1, 2 lots of 2 is 4, take away 3 is 1, 2 lots of 3 is 6, take away 3 is 3, and 2 lots of 4 is 8, take away 3 is 5. So we're just substituting each of those x values into that equation, timesing it by 2, taking away 3 to find out what y is. And now each of these is a coordinate that lies on the line. So minus 2 minus 7, that's down here, minus 1 minus 5, that's there, 0 minus 3 is there, 1 minus 1 is there, 2 1 is here, 3 3 is here, and 4 5 is here. And then we're just going to join that up with a nice straight line going through all of those points. And that is the line y equals 2x minus 3. Some of you may also know that there are 2 pieces of information here. The gradient is 2, the steepness is 2, we're going up in 2s, that's the number in front of the x, and the other number is called your y-intercept, and that is just where it crosses the y-axis. So you might use that to help you as well, but there we go, 4 marks usually for that. Oh, only 3 marks on that one. Outrageous. We'll take it though. Okay, question number 23. A container is in the shape of a cuboid. The container is 2/3 full of water. A cup holds 275 millilitres of water. What's the greatest number of cups that can be completely filled with water from the container? So to get the volume of a cuboid, we do base times width times height. Basically 30 times 6 times 19. So if I'm multiplying that together, 30 times 6 times 19, again I'm using my calculator because this is a calculator paper, 3,420 centimetres cubed. But the lovely thing about centimetres cubed is that that is the same as millilitres. So that's also 3,420 millilitres. Now this is not full, it's only 2/3 full. So I now need to do 2/3 of 3,420. Now remember, when we find a fraction of a number, you divide by the bottom and then times that by the top. So 3,420 divided by 3 is 1,140, then times that by 2, and that is 2,280 millilitres. So that's how much liquid we've got in the container, and we're now going to share that into 275 millilitre cups to see how many we can completely fill. Now, if we're sharing it into cups, we know that that means we need to divide. So 2,280 divided by 275 is going to be 8.290, and the 9 and the 0 are recurring. Now, even if that was 8.8, we wouldn't round it up because it's saying how many cups can we completely fill with water. And so it's just going to be the whole number part. So 8 cups would be your final answer. If you wrote 8.29 on the answer line, you are going to lose marks there because it said what's the greatest number of cups that can be completely filled. And that's just going to be 8 with no remainder left over. We want them to be completely filled up. Okay, question number 25. Sally used her calculator to work out the value of a number y. The answer on her calculator began 8.3 something, we don't know, okay? Complete the error interval. So imagine You just can't see the numbers that are coming next. With an error interval, it's asking you what is the absolute smallest that the number could have been, and we're going to put that there, and what is the absolute biggest that the number could have been. So the smallest it could have been is 8.30. It could have been that behind that squiggle there is just nothing. It's either a 0 or it's blank. That's what's next. So 8.3 is the absolute smallest it could have been. And the biggest it could be is 8.3999999. So 9 recurring. Okay, that is the absolute biggest it could be. But because 9 recurring is so infinitely close, it's basically 8.4, we just say it's 8.4, and that's why at this top end it's not equal to. It can't actually be 8.4, otherwise we would have seen a 4 here, but it can go so infinitely close to it that we just say it's 8.4, but we say that it's not equal to that. It's just everything up to that. So 8.3 and 8.4, and that's called truncating. It comes up occasionally. Normally when we see that topic, it's rounding, but truncating is 8.3 and then one above, normally 8.4. Question number 27, write 0.00562 in standard form. So standard form is when we have the digits written between 1 and 10. So in this case, 562, I'm going to write 5.62 because it has to be between 1 and 10, times 10 to the power of something. Now it's always times 10, even if it's a really, really small number where clearly we're dividing by 10, or if it's a really, really big number like 5,620,000 or whatever, we're always going to put times 10. And then if you've got a really, really small number like you do here, the power is negative. If you've got a really, really big number, then the power is positive. So in this case, we've got a really small number. That power is going to be negative. How many times would I be dividing by 10 to get from this to what we have here, this? So that's going to be divide by 10, divide by 10, divide by 10. That 5 has gone from being in the ones column to being in the thousandths column. And so we are going to say that's times 10 to the power of minus 3. The number of zeros does always match up on the negative ones, but not on the positive. So never rely on that too much. Okay, and then part B, write 1.452 times 10 to the power of 3 is an ordinary number. So this means times it by 10, times it by 10, times it by 10. So if I times it by 10 once, I'm going to get 14.52. If I times it by 10 again, I'm going to get 145.2. And if I times it by 10 again, 1,452. 1452. So that is it as an ordinary number. This is in standard form. Question number 10. Mary travels to work by train every day. The probability that her train will be late on any day is 0.15. Complete the probability tree diagram for Thursday and for Friday. So we know with probability trees that the probability of each branch needs to add to make 1. So if the probability of her being late on Thursday is 0.15, then the probability of her not being late is 0.85, because that is 1 take away 0.15. These two branches together need to add to make 1. Now it says the probability of her train being late on any day is 0.15, so we know that even if it's Friday, that's going to still be 0.15 and 0.85. If she's late on Thursday, that gives us the option for Friday. And if she's not late on Thursday, we've still got the option for Friday. So these are just going to be the same. It doesn't make a difference whether she's late on Thursday as to the probabilities on Friday. It just says any day, 0.15 of being late. Work out the probability that her train will be late on at least one of these 2 days. So we are interested in her being late on 1 day or 2 days. Now the reason we also want to include 2 days is because it says at least one of these days. Probability, we times along the branches and we add the ones we want. So there are 4 things that can happen here. Either she can be late on Thursday and late on Friday, or she can be late on Thursday and not late on Friday, or she can be not late on Thursday and then late on Friday, or not late either day. Now there's a lot of different ways we can do this. If we are interested in these 3 situations, late, not late, late, and also late, late, I actually want to times along the branches of those 3 pathways. So late on both days is 0.15 times 0.15. Late and then not late is 0.15 times 0.85. Not late and then late is 0.85 times 0.15. And not late, that's 0.85 times 0.85. We don't need that one. So we're just working out the top three. 0.15 times 0.15 is going to be 0.0225. 0.15 times 0.85 for that second probability, that's going to be 0.1275. And then 0.85 times 0.15, that's the same question, so 0.1275. And then for the bottom one, we don't need to do it, but I'm just going to do it so I can show you a different way we could have done this, is 0.7225. Okay, so then we want the probability of her being late on at least one of these days, and that's going to be this answer, add this answer, add this answer. So we times along the branches and add the ones we want. So 0.0225, add 0.1275, add 0.1275. Adding those three answers together, 275, add 0.1275, add 0.0225, I get 0.2775. So that is the correct answer for this question, 0.2775. Now that was quite a lot of work. What we know is that with probability, this answer and this answer and this answer and this answer actually add up to make 1. So if you know you want these three, you could just do 1, take away that bottom one. And then you'd only have one of those sums to do. So 1 minus 0.7225 actually gives us the exact same answer of 0.2775. If that makes sense, great. If it doesn't, don't worry too much, whichever way works for you. So timesing along the branches of the pathways that you want and adding those ones up. Okay, question number 12. OAB is a sector of a circle with centre O and radius 7. The area of the sector is 40. Calculate the perimeter. So we cannot calculate the perimeter. We don't know how long this section is until we've worked out how many degrees this angle is, because I don't know what fraction of the circle I'm interested in. If we're told the area is 40, we know that pi r squared times x out of 360 needs to equal 40. This is how I work out the area of a sector. It's the area of a circle, that's the formula for the area of a circle, times by the fraction that I'm interested in. Now I know the radius is 7, so pi times 7 squared, or 49 pi, times x over 360 equals 40. I'm going to try and solve this. I'm going to divide this side by 49 pi, and I'm going to divide this side by 49 pi. So 40 divided by 49 pi gives me 0.259844805. I don't want to round anything just yet because I haven't got to my final answer. And then to work out what x is, well, x at the minute is being divided by 360. So if I times both sides of this equation by 360, that will give me the angle. So I'm actually not going to clear that from my calculator. I'm just going to take the 0.2598 that's in my calculator and times it by 360, and that gives me 93.544 degrees. Now, I might just do a few more decimal places at the minute, okay? Because I'm going to carry on and use that in a second. So that is that angle, 93.544. degrees. Now we want to work out the perimeter. So the perimeter is made up of 3 parts. If they just asked me for the arc length, then I'd just be working out that bit. But perimeter goes all the way around the outside of a shape. So I need the arc length, and I'm going to add 7 and add 7 so that I get all the way around the outside of a shape. Now arc length is pi d, that's the circumference, times the number of degrees we're interested in, x, which we now know is 93.544, out of 360. The diameter of this circle would be the distance all the way across. If you imagine it was a full circle, then the diameter is 14. So pi times 14 times, and I'm actually just going to use the answer button in my calculator because I've still got that X answer in there, and that's just going to keep it super accurate. So I'm going to type pi times 14 times, and then I'm using that fraction button, I'm putting answer on the top and 360 on the bottom. And that gives me 80 over 7, which is 11.428571. All of that is recurring. That is your arc length. So to get the perimeter, I now just need to add 7 and add another 7, or add 14, however you want to say it. And that gives me a final answer of 25.428571. And it says round your answer to 3 significant figures, so 25.4. The next number is a 2, which rounds down, so 25.4 is my answer for the perimeter of that shape. Question number 14, a car moves from rest. The graph gives information about the speed. So we've got speed on the y-axis here and time on the x-axis. Calculate an estimate of the gradient of the graph when time is 15. Now, the most common mistake I see is people know gradient is rise over run. So what they do is they go to 15, they go up, they go across, and then they just tell me this number divided by this number. That is not the same, okay? What you need to do is draw a tangent at that point. So we're going up at 15, we're hitting that point, and I want to know how steep is the graph at that point. So you're going to draw a tangent, and a tangent should ideally match the gradient of the graph at that point. So it should try and be the same distance away from the curve on both sides. And we're going to turn it into a triangle, and we're going to work out the gradient. Now, don't worry too much about how big your triangle is. You need to go big enough that it's accurate enough. If you go too small, you might lose accuracy. So you want to kind of go big enough. That looks about right to me. And now I've given myself a tricky task because I've not really thought about where I've landed when I've done that. But there we go. This here is 12.5 and this here is 22.5. Therefore, my rise is 10. On the x-axis, I can see that it goes 6, 7, 8, 9, 10. So this here is 7. And here on this axis, that's 21.5. So how much has it gone across by from 7 to 21.5? I'm using my calculator because I can. 21.5 take away 7 is 14.5. So rise over run for the gradient. The rise is 10. The run is 14.5. 10 divided by 14.5 gives me a gradient of 0.689. Like that. So I'm going to put 0.69 as my answer to that. There would be a range of answers. I will pop it in the description down below, the range of answers that you would be allowed for that question. Describe what your answer to part I represents. So with this graph specifically, it is a speed time graph or a velocity time graph. The gradient of a velocity time graph is the acceleration. It's the rate of change of speed, which is the acceleration. If you had a distance time graph, then the gradient represents the speed or the velocity. But because this is a speed time graph, the rate of change of speed is the acceleration. Part B, work out an estimate for the distance the car travels in the first 20 seconds of its journey. Use 4 strips of equal width. So what we now need to do is go back to that graph. I'm actually going to clear everything that I've done so far just to make this a little bit easier for me to draw. Let's delete that. Let's delete that. Now, it actually tells you how many strips to do. So first 20 seconds of a journey and 4 equal strips. So that means we need to do a line here, we need to do a line here, we need to do a line here, and we need to do a line here. And what we're doing is we're estimating the area underneath the graph. And we're doing that by turning these into trapeziums. Now, you can do the area of trapeziums. My personal experience, having taught as many students as I have, is that students prefer to split it into rectangles and triangles. If you want to use a trapezium, or if you want to use a trapezium rule or anything like that, that's absolutely fine. I personally like to make it rectangles and triangles because I feel like students are more confident with that. So the first part is 5. Now remember, we're going up in twos here. So 5 times 4 divided by 2 because it's a triangle. and that is 10 for that first section. For the next section, we know this has a height of 4, so this is 5 times 4, that bit is 20, and for the bit above, I'm going from 4 up to, that's going to be 12, so that's 8 for the height, 5 for the width, so this bit is 5 times 8, which is 40, divided by 2, which is 20. For the next section, 5 times 12, we're going up to 12 here, 5 times 12 is 60, and for the triangle at the top, the height here is going to be 16, 17, 18, so that is 6 times 5 divided by 2, 6 times 5 divided by 2 is 15 for that section. We circle these so I don't lose track of what my areas are, and then up here, this is going up to 20, so this has a height of 2, a width of 5, 5 times 2, divided by 2 is just 5, so I've got 5 for the area of that bit, and then the rectangle is 5 times 18, which is 90. Adding all of that together, I've got 10, add 20, add 20, add 60, add 15, add 90, add 5, and that gives me a final answer of 220. Now the speed is in meters per second, and the time is in seconds, so that distance that we found, the area underneath the graph, is the distance, and that is 220. Let me just write my working here. 10, add 20, add 20, add 60, add 15. What was it? Add 90, add 5. Did I do them all? 1, 2, 3, 4, 5, 6, 7. Yeah, that was it, wasn't it? 1, 2, 3, 4, 5, 6, 7. Yes, good. Got them all. 220 as my final answer. Okay, question number 16. The straight line L has the equation 3y equals 4x add 7. The point A has coordinates 3 minus 5. Find an equation of the straight line that is perpendicular to L and goes through A. So first I'm going to take this line here, 3y equals 4x add 7, and I need to know the gradient of this line. To do that, we need to make y the subject of the formula. So I'm going to divide this side by 3 and divide everything on this side by 3. So y equals 4 over 3x add 7 over 3. Normally we'd put it all over 3, but the problem is that I want the gradient, which is just this bit in front of the x. So that's what we need to take. If I was asking you for a line parallel, then I'd be asking you for a line with the same gradient. This, I'm asking you for a perpendicular line, so we need to do the negative reciprocal. The reciprocal of 4/3 is 3 over 4, and because this bit is positive, we need to make ours negative, because if this line is going up, the perpendicular line will be coming down. So the negative reciprocal for perpendicular lines, y equals minus 3/4 x plus c. We don't know the y-intercept, but we do know that we need to go through this coordinate. Now the coordinate 3 minus 5 has an x coordinate of 3 and a y coordinate of minus 5. So I'm going to substitute that in to help me here. Minus 5 is minus 3/4 times 3. I've changed the x to be 3 and the y to be minus 5. Minus 3/4 times 3 is minus 9/4. So minus 5 equals minus 9/4 add c. And I'm then just going to add 9/4 to both sides. So minus 5 add 9/4 is going to be minus 11/4. So my final answer, that tells me what c is, by the way, minus 11/4, and you can write it as minus 2.75 if you would like. My final answer for my perpendicular line is y equals minus 3/4 x minus 2.75 or minus 11 over 4. That is perpendicular and going through 3 minus 5. Question number 18. The points A, B, C and D lie on a circle. CDE is a straight line. We've got BA is equal to BD, which we can see because it's an isosceles triangle. B is equal to CD, so we've got another isosceles triangle on the side there. An angle ABD, which is labelled for you, is 40 degrees. Work out the size of angle ADE. You must give reasons for your answer. So I'm going to go ahead and put an X here. That's what we're trying to work out. Okay, so first things first, we've got an isosceles triangle. So I know that these two angles are the same. I've got 40 degrees at the top, so 180 degrees in a triangle. Take away 40 leaves me with 140, and I'm going to divide that by 2. 140 divided by 2 is 70 degrees, so I've got 70 degrees here and 70 degrees here. That's the first step. The next step, I'm going to use the fact that I know that this is a cyclic quadrilateral. So a cyclic quadrilateral is when all four corners, all four vertices of a quadrilateral touch the edge of a circle. And when that happens, the opposite angles add together to make 180. So if I know that this angle here is 70 degrees, then I know that this angle over here is 110. And that's great because that also tells me this angle in an isosceles triangle, I'll have 70 degrees left. So 180 take away 110 is 70, and again we can divide that by 2 to get 35. So I've got 35 degrees here and 35 degrees here. We've then got a straight line here, so I'm going to add together the 70 and the 35 to get 105, take that away from 180, and that gives me more on the floor, but from next door. 7 take 0 is 7, 1 take 1 is nothing. There we go. So I've got 75 degrees there as my missing angle. So that's great. That would get me probably 3 marks, but I'm going to lose 2 marks because at the minute I've not given a reason for each stage of my working. So what have we used? So we used angles in a triangle, add up to triangle, add up to 180. We also said that opposite angles in a cyclic quadrilateral, that being one where all four corners touch the edge of the circle, quadrilateral, add to make 180. And we also use the fact that base angles in an isosceles triangle are equal. And then we also used angles on a straight line. So lots of reasons that we used angles on a straight line, and you do need to write them all for full marks. I know it's frustrating. Angles on a straight line add up to 180 degrees. Perfect. They need to be connected. I normally like to write it a little bit neater than that and show. So, for example, where we've done this one, link that to that reason there and so on. So that's perfect for question number 18. And last but not least, question 20, and we've got vectors here. C, D, E, F is a quadrilateral. C to D is A. Now, as soon as they give me vectors, I like to draw them on. C to D is A. D to E is B. So all of that is B. And I like to do an arrow so we know which way we're going. F to C is A minus B. That's that one. Express F, E in terms of A and B. So we've got to get from F to E. F to E. So this way. Now, we don't know how long this is. We've got nothing here, but I do know that we can just go round. So if I want to get from F to E, I'm going to go up here, along here, and down here because I have all three of those vectors. So I know it's going to be A minus B because I'm going up here first. Then it's going to be add A because I'm going along there. And then add B. All the arrows were going in the right direction. And then we just need to collect like terms. So I've got 2A in total, and then the minus B and the plus B just makes 0. So 2A. So we can pop that up there as well. Makes sense. It looked like it was parallel. You can't ever assume, but if it's a multiple, so like A and 2A, that's a multiple, therefore it's going in exactly the same direction. It's twice as long as well. Okay, M is the midpoint of DE, and X is the point on FM such that F to X, X to M is in the ratio N to 1. CXE is a straight line. Work out the value of N. So I'm just going to try and do it all up here without scrolling. What they want is they're saying this line here is in the ratio N to 1. So if I can work out what F to X is, and then I can work out what F to M is, then I can compare that and get that ratio. I know also they've just told me that CXE is a straight line. So therefore, C to E we can get by going round. C to E is A plus B, okay? And therefore C to X, well, I don't know how far down C to E that is, but I know it's going to be some fraction, some number. So I'm just going to call it N. A plus B. That makes sense to me. N lots of A plus B, okay? Now, there are other ways we could get from C to X. We could also say that to get from C to X, I can go down here and up here, okay? That could be a route that we could take. To do that, we'll need to work out what F to M is. So F to M, again, I'm going to go round the outside. It is A minus B, add A, add a half B. And that comes together to be 2A minus b add a half b is minus a half b. So that's f to m. Now if I want to go f to x, again it's going to be some fraction of that. I'm going to use k. I don't know why I'm picking random letters here, but hopefully that makes sense. So f to x, it's just some multiplier. It's not an actual, it's not going to add any more a's or b's. We know it's parallel to f to m. It's just some proportion along it. So it's k brackets 2a minus a half b. So then c to x, we can go that way. We can say it's down here and up here. So c to x is going against this vector. So that's going to be minus a add b, add k lots of 2a minus a half b. So simplifying that, we've got minus a plus b plus 2ka minus a half kb. Now you might think, what's that achieved us? What we can now do is compare this to this. This tells me that whatever number is in front of a and b is the same. So it might be 2a plus 2b, or 3a plus 3b, or a half a plus a half b more likely. It's going to be the same number in front of them both because it's just a scalar, it's just a number in front. So what I now know is that the number here, which is just minus 1, add 2k, so minus 1 add 2k needs to be equal to whatever number is got from this term and this term, if that makes sense. So plus 1 minus a half k. So those two things have to be the same. Now let's just solve that equation. So 2.5k equals, and I'm adding 1 to both sides, equals 2. So k equals 2 over 2.5, which I'm just going to double, 4/5. Okay, so 4/5 is going to be the value of k. I can then put that back in up here where I've got k. So I now know that f to x is 4/5 of 2a minus a half b, which is 8/5 a minus 4/10, or 2/5 I should say, b. Good, so that gets me from f to x. Now what I need to do is compare this to f to m, which is the whole way along this. If I know that f to x is 8/5, and I know that to get from f to m, I'm just looking at the a term because it's just the easiest thing to do, f to m was 2a, then x to m, the rest of that line, must be the rest, okay? So 8/5 is just 2/5 away from being 2 wholes. So 8/5 to 2/5, and I'm going to times both sides by 5, which gives me 8 to 2, which simplified gives me 4 to 1. So therefore it's 4. The number they're looking for is 4. I think that's way beyond grade 9. I don't know, a very, very challenging question. I've seen another one quite like it that I've posted on TikTok. But yeah, a very, very, very tricky last question. So really well done if you followed along, or if that made any sense, or if you picked up any method marks at all. If you've got any questions at all from today's paper, let me know in the comments. I'd be happy to help. Join me next week for week 11.